Okay, we've covered the greatest common divisor of A and B, just written like that. Now I'm going to cover anything, the least common multiple of A, B, which doesn't have a notation, it's just LCM of A and B, like this. And you've seen this for fractions. If I want to add 1/6 to 1/10, well, we all know that we can do it in terms of 60ths. We can take 10 60ths plus 6 60ths, 16 60ths, which is fine as far as it goes. But then of course I can cancel 38 and cancel another 2, 15 and 4 to give me 4 15ths. Well, that's great, but we don't need to go up as far as 60. We can just go up and do it in 30ths. We can say 1/10 equals something 30th plus something else 30th, and which way around is it? It's 5 plus 3, which is 8 30ths, which then of course cancels to 4 15ths again. This 30 here is the least common multiple of 6 and 10. So it's a multiple of 6 and 10, and of course 6 times 5 equals 30, and of course 10 times 3 equals 30 as well. So 30 is a multiple of 6, it goes in 5 times, and 30 is a multiple of 10, it goes in 3 times. So this is called the least common multiple. Not as often used as greatest common denominator. It's interesting because it bears a peculiar relationship to GCD, and I'll write it out. A and B are given integers. The greatest common divisor of A and B times the least common multiple of A and B equals AB, just AB multiplied together. And you can kind of see why that is. If A equals P1 to the alpha 1, P2 to the alpha 2, P3 to the alpha 3 all the way along, and some of them might be zeros to P, let's say n, alpha n, that's the prime factorisation of alpha. B equals P1 to the beta 1, P2 to the beta 2, up to Pn to the beta n. You'll notice that I can stop at a particular point because these numbers here are finite, they've got a finite factorisation. Well, the greatest common denominator of A and B equals P1 to the power, it's going to be the minimum of alpha 1 and beta 1, P2 to the minimum of alpha 2 and beta 2, times all the way along to Pn minimum of alpha n beta n. And of course we're going to do the same thing for the least common multiple. Is P1 to the maximum of alpha 1 beta 1 times P2 to the maximum alpha 2 beta 2 times blah 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 times Pn maximum alpha n beta n. Okay. So for any case, we've got the minimum plus the maximum, which is going to be equal, the minimum of these guys plus the maximum of those guys is going to be equal to alpha plus beta, isn't it? Because if alpha is smaller than beta, then we've got the minimum, which is alpha, plus the maximum, which is beta, and if it's bigger, it's going to be the beta plus the alpha. So in each case, we've got the P1 to the alpha 1 plus beta 1 up to Pn to the alpha n plus beta n. Not fully rigorous there, which equals AB, of course. Not fully rigorous, but that'll do. So, the greatest common denominator of A and B times the least common multiple of A and B equals A times B. Okay, really nice. I'm going to stop there.